Good morning, everyone. It's Mr. Slomka here, and I wanted to spend some time talking to you about section 8.3 today. So let's get started. In 8.1, you guys had learned what a sequence was, and in 8.2, you learned what an arithmetic sequence was. In 8.3, I want to talk to you about geometric sequences and series. So a geometric sequence is going to be a list of numbers. That is true for any sequence at all. The main thing about a geometric one is that the pattern that it's going to follow is going to be a multiplication or a division pattern, which is a little bit different. Arithmetics use the addition or subtraction. Let's take that a little bit further. So now, when we're talking about that multiplication and division, the main thing that we're going to refer to it as is as the common ratio, or the R value. The common ratio is going to be the number that you multiply to produce the next value in the sequence. You can also divide, but most of the time we're just going to multiply. I'll tell you why division's in there in a couple of seconds. Let's take a look at a couple of sequences of numbers and see if we can analyze them a bit closely. So now this is a really, really great example question because this is something that we've been building up to. In the past, we've looked at some sequences and you've decided whether they're arithmetic or not. And now what we're going to do is we're going to try to decide if these sequences right here are arithmetic, geometric, or neither. So this is going to be the best version of the question that we've seen so far. So it could be arithmetic with a difference, or it could be geometric with a ratio, or it could be neither. So let me show you a couple of things. First of all, if you're a very bright person, you might be able to just look at the list and tell how you get from one number to the next. And if you can do that, that's awesome. Good for you. You're great. But if you are not so sharp like that, then you might need a strategy. So let me show you one. What I like to do when I'm working on these problems is I actually work from right to left. And so I'm going to work backwards a little bit. And instead of trying to come up with some mystery number, I'm going to let my math come up with a number for me. I'm going to start over here at the 54, and I'm going to try to do a little bit of division. And when I do this division, I'm going to see if I can get the exact same number every time. So 54 divided by 18 is going to give you 3, and 18 divided by 6 is going to give you 3. You see how the same number is showing up over and over again? That makes me think that it's going to be geometric. But here, 6 divided by 3 is not 3. It's actually 2. So that is not so good. I'm not a fan of the fact that I got a 2 right here. So if this division had worked, it would have been a geometric. Now you can do the same kind of idea a second time as well, but this time you can do subtraction. If you do it with subtraction, it should be arithmetic. Now right off the bat, I can tell that subtraction is not going to work because 6 take away 3 is going to be 3, but 54 take away 18 is not going to be 3. So that one is not going to be the one that we want. So that means that it is not arithmetic and it is not geometric, and that means that this one unfortunately is neither. It is important to be thorough when you use this technique to make sure that you check all the numbers, not just the first two over here or the first two over here. Let's take a look at another one. So now our second one right here is going to be another set of numbers, and this time what we want to do is we want to start once again from the far right and work our way to the left, and we're going to just test all the way through. When you're testing some of these bigger numbers, you're going to want to divide them. One of the things I'd like you to notice while we're doing a division right here is I want you to notice that the signs are changing. We have a positive and then a negative and then a positive and a negative and another positive. This right here is a real telltale sign that division will be your best option, which means that it is most likely geometric. This time when you do your division, you do get the same number every time, and that number is 3. With a negative sign on it. That means that it is going to be a geometric right there, and our ratio value, which is going to be a very important number to us, is going to be -3. Here are two you-try-it problems as well. I'd like you to pause the video and check those out if you're curious in trying them. So there's your two you-try-it problems right there. Great. Let's talk about the formula. So now our formula is right down here at the bottom of the page, and this is going to be for geometric sequences. This formula is very similar to the arithmetic one that you've already had as well. So what you have right here is you're going to have a formula that's going to start with AN. That's a general statement, so we're going to keep that one the same. Then we're going to have A1, which is going to be your first term. You're going to replace that with a number. You're also going to have R, which is going to be your common ratio, which is just what we found, and that one's going to get replaced with a number. This right here is an exponent. And so that exponent is going to have your n and your -1. Remember that the n represents the term's location or the term's number. Let's try a problem out down here at the bottom. So we have another set of sequences just like we had at the top. Now a big difference right here is that they say specifically that these ones are geometric. So you don't need to do any testing. The division will work every time. And so that's going to be really, really nice. Okay, so let's see if we can build ourselves a rule. When it says rule, what it really means is build one of these formulas. So we're going to try to do just that. So let's see if we can do it. Let's start off by collecting some information. The two big important things we need is the first term and the ratio. So for our first term, you're going to look in the first position, which is going to be this 5 right here. I know that earlier I said work from right to left, and you are going to do that, but we're not going to start with our first term being 135, but rather just 5. Now for your ratio, this is where you're going to want to work from right to left. Once again, if you just see it, you're like, oh, I know what I need to do to a 5 to get a 15, and I know what I need to do to a 15 to turn it into a 45. Great. If not, then you're going to have to use my division trick. And the division trick will also give you the same number as long as you work from right to left. When you do the division, or if you just look at it, you should once again see 3 is an important number. 5 times 3 is 15, and 15 times 3 is 45. 135 divided by 45 is 3 as well. So 3 is going to be the guy. With the 5 and the 3, that's basically all the information that you need, and so you should be able to write yourself a rule. And it's going to look like that. Now, second part of the problem, second part says then find A8. For A8, what you're going to want to do is you're going to want to take your rule and you're going to want to plug in the number 8. When you're working on this rule right down here, make sure you follow your order of operations. So we're going to start with our exponent, which is going to be 5 times 3 to the power of 7. Then you're going to want to find out what 3 to the power of 7 is going to be, which is 2,187. And then lastly, you're going to take your 5 and multiply it by that 2,187. Even though 5 is the first thing that you write down, it's the last thing that you use. And so that is a little bit backwards. For our second question that we have right here, this one's for you to practice. You have an A1 value of -4, an R value of -2. Your rule would be -4 times -2 to the power of n minus 1. And your 8th term would be 512. Thanks so much. I'll have a second and a third video on this lesson up in a couple moments as well.